welcome back to the Tech channel. In today's video we're going to be discussing algorithms. Today we're going to be discussing algorithms. Today we're going to go through what an algorithm is, some of the computational thinking terms you'll need to make an algorithm, the different ways of representing an algorithm, and also some ways of sorting data using algorithms. Algorithms. I know that this word may seem a little bit daunting to some of you, but the thing is that algorithms can be described really simply. An algorithm can be described as a set of instructions for performing a task or completing a problem. Yeah, that is the most basic description of an algorithm, and there are a few words that you need to know in order to kind of talk about algorithms correctly, and those two words are decomposition and abstraction. Now, again, scary computer science terms, don't worry, I'm going to put it in layman's terms for all of you. So decomposition is simply breaking down a large problem into smaller and more manageable sub-problems. That's all decomposition is. Not so scary, is it? And next we've got abstraction. Now all abstraction is removing unnecessary details from the problem to focus on the main task. So maps, for example, or money are a good example of decomposition in everyday life. So these two terms right here, you're definitely going to have to remember them, because when talking about algorithms, you basically need to learn these. Now, algorithms can be presented in two different ways. We have flowcharts and pseudocode. Now, both of these are very different, and in order to explain what each of them are, I'm going to have to switch screen. So, bam, the screen has now gone completely white. So, flowcharts. We're going to start with flowcharts first, as they're a lot easier to explain. So, flowcharts are a visual way of representing algorithms. So, they use shapes to show what the algorithm does. And so these shapes are, so you've got oval, which represents start/stop. You have a diamond shape for representing a decision, so that might be, I don't know, deciding what kind of flavour you want for your cake. You'd use a diamond for that. You've got a rectangle for processing, so that may be calculations. We also have parallelograms. I'm getting a bit obscure with our shapes now, and these represent an input/output. Now these are the main shapes you'll need to know if you want to draw a flow diagram, and these are all linked together with an arrow which represents the direction of process. So it's going to it directs to you how things are executed. There's also a few other shapes that you might need to know, such as sub-processes, which just looks like a normal rectangle but has lines here and here, but you don't really need to know that at this stage. So, a good example, I'm going to make a quick flow diagram for you, and I'm going to talk you through as to what it does.
A few moments later.
This is my very wonky flow diagram. Ignore my artistic skills. Drawing on a drawing tablet is hard when you're having a lot of practice. So, as you can see, here we have the start, and then it'll ask the user for an input, and it'll be stored as a variable called num. Now, then it will do num add 5. Now, if num is greater than 10, it will say yes, and then so it will output yes and then end the program. But if it's not less than 10, it will output no and then end the program. So this is just a very basic flow diagram. They can get quite advanced, and if you want to write flow diagrams, there'll be a link in the description to a really good website. I know that it makes writing flow diagrams a lot easier. Next up, we've got pseudocode, the bane of my existence. So, pseudocode. Unlike flow diagrams, which are a visual representation of an algorithm, a pseudocode is literally just writing code that uses English-like statements that kind of resemble the syntax of a code. But you must remember this. It is not code. It cannot be run on a computer. You must remember this. You don't want to confuse Python and pseudocode for your exam. But it uses English-like statements to kind of make you think it's code. So it uses stuff like user or output, whereas something like Python would use input and print for these two things. So, I'm going to write down a quick example of pseudocode.
2,000 years later.
Right, so this is just a pseudocode representation of the code we wrote in the flow diagram earlier. So what this does is this outputs the word number and then takes in the user input and and stores it in a variable called number. Now if number is larger than 10, then it'll output yes. If it is not larger than 10, it'll output no. So this is a good example of pseudocode, a very basic pseudocode program that can very easily be translated into Python, Java, C, whatever you're coding in. Right, so now we're going to do search algorithms. Now, search algorithms sound scary, much like algorithms as a whole, but they're not, because I'm going to explain them to you. Now there are two main ones that you need to know, these being linear and binary. We're going to start off with linear. Now, as the name suggests, linear searches will search through every single bit of data in the dataset you've presented it to look for the desired value. It looks through every data piece. And the second one you need to know is binary search. And what this does is this works a bit differently to a linear search. What it does is it will calculate the midpoint of the dataset you've given it and split it in half. If the desired value is like more than the midpoint, it will check the right dataset is just split in half. If it's less, it will check the left side, and it will continuously split them in half until you get the desired data set. So say for example I had the data set 1, 3, 17, 9, 19 and 21 and 69, haha lol. So what it would do is it would find the midpoint of these two of this data set, and it would split it in half. So in this case it would split up into 1, 3 and 17, and then 19, 21 and 69. So say I'm looking for 69. What it would do is it would check to see what part 69 is in. If it is larger than the midpoint, which is 19 in this case, it's going to check the right side. So we can ignore this now because it's not in there. Now what it will do now is it will divide it in half again. In this case it will be 19 on this side and then 21 and 69 on this side. 69 is quite a bit larger than 19, so it will get rid of 19 and it will divide it again into 21 and 69, and then it will check. So it's definitely not, that's 21 is not the desired number we've been looking for, so that means that 69 is, meaning it has found the desired number, and then once it's finished it will just end the algorithm. Now there are some advantages and disadvantages to the two different searches. So linear search, they are easy to implement, they're easy to debug, and also the list doesn't have to be ordered. You'll notice in my example with the binary search the lists were technically in ascending order. Now those are some of the disadvantages. Unfortunately there are some disadvantages as well as advantages, those being it is less efficient and therefore takes longer. Now binary searches on the other hand are very efficient. They also just work a lot quicker, but there is quite a few more disadvantages. So the list needs to be ordered for a start, because it's got to find a midpoint between two ascending data sets. They are very difficult to program. They're also hard to debug. This has to be sorted. They're hard to debug and they are extremely hard to program. Most people, if you have quite a small data set, most people will just go for linear searches, but if you've got quite a large data set that has lots and lots of numbers in it, most people will go for binary searches, because the extra bit of pain that it causes to actually set them up is definitely worth it, because there's just so much more data in the data set. Next thing we're going to look at is sorting algorithms, because let's say you got a really large data set and you want to use a bubble sort, but the data isn't ordered. This is where sorting algorithms come in. So there are two main ones to discuss. We're going to discuss bubble sort first. So what a bubble sort does is, so say I had this list. We've got 2, 1, 5, 9, 16, 0.5, 15 and 12. There you go. Definitely not in ascending order. I'm just going to put some commas in between these just to break them up a little bit. So we've got this. So what a bubble sort does is it will compare two bits of data, and if they're in the incorrect order it will flip them. So on the first pass what it'll do is it will check 2 and 1 here, and they're definitely not in the right order, so it will flip them. Now meaning that the set now looks like this. And bubble sorts do multiple passes. So next it will compare 2 and 5. They're in the correct order, so it will leave them alone. Then 5 and 9, also in the correct order, so it will leave it alone. 9 and 16, correct order. But 16 and 0.5 are most definitely not in the correct order, so it will flip them. So the dataset will now look like this. But then it'll look at it again, it'll say, hang on a minute, 0.5 and 9 still not in the same order, so it will flip it again. And then it'll go, hang on a minute, 5 and 0.5 Still not in the same order, so it'll flip it yet again, and then it'll just continuously, you know, flip between the two until 0.5 is in the correct place, and it will continuously do this until the entire list is ordered, which it will eventually do after, you know, quite a few different passes. Which is one of the main disadvantages of a bubble sort. It may be good at sorting, but the thing is that because it does so many passes, it's not very efficient and it does take a very long time. But it is very popular for small data sets like in this example here. And basically as soon as the algorithm's done, it will just output the ordered list and then just stop running. So yeah, they're very low maintenance, a lot easier to code than a merge sort, which is what we're going to look at in a minute. But yeah, I wouldn't recommend it if you've got a very large data set. Final thing we're going to look at in this video is merge sort. Hooray, my favourite not. Merge sorts require a lot more explanation than they do diagrams. So, put the pen down, and I'm going to flip back into just camera me. Merge sorts, very efficient and very effective at sorting large data sets. So what it will do is it will take the data set and then divide it in half, much like with a binary search. Basically, it will divide and divide and divide. So say it will just divide and divide and divide until the data set are in little chunks of 2, and then if the two numbers are not in the correct order, it will flip them and then it will just jam them back together. Now, let's face it, the list will definitely not be in the correct order, so it will continuously split them, flip them, and jam them together until they are in the correct order. That's basically how a merge sort works, and this is why it's very effective at sorting large data sets, because it does it quicker and it does the process of split, flip, jam. So, I hope you enjoyed this video, guys. It's a little look into algorithms. If you did at any point, consider liking and subscribing, as it really helps this channel out. And I'll see you in the next educational video, whenever that may be. Bye.